going over these problems is put a warm up on the backboard. So you have if you have x squared plus y squared equals 36, and then you have y equals x squared, what would the solution be equal to? Now I should give it as an ordered pair. So let's think about this particular type of problem. What does this look like? It's a circle with a radius of what? 6 and a center of what? 0, 0. Okay, so this, I have a center here, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and then the other equation, I have y equals x squared. What is this? It's a parabola. Vertex where? 0, 0. Okay? And then this is going to go right 1 up 1, left 1 up 1, right 2 up 4, left 2 up 4. So that's what this picture is going to look like. How many solutions does it appear we have, and what would a solution be defined as? How many solutions does it appear we would have, and how would we define a solution? There's 2 of them. Why is that? They intersect twice. So we're going to have 2 answers to this problem, 2 ordered pairs. So this is going to be an ordered pair here as well as here. So I have x comma y here and x comma y here. What can you tell me? What can you tell me just by your knowledge of a circle or a parabola? What can you tell me about the y values? What do you think? They'd be the same. I'd go up the exact same amount. What can you tell me about the x values? What? Nice. They're opposite. So like if we had 1 comma 2, the other answer would be negative 1 comma 2. So the y components are the same, but the x components are opposite sign values just because of where we fall in this case. How would I go about solving this problem? I mean, I have it graphically kind of solved, but how do I get those ordered pairs? Oh, hey, Jenny, I got your notes, so sorry about that. Hey, what time did you come over here? On Friday? Oh, what period? You went upstairs, and was the office closed or was it open? No, it was open. It was open, I just wasn't there? Music wasn't on yet? Okay, I wasn't there yet. I'm sorry. I'll get it. Yeah, how will we solve that problem? How will I get those actual points? What do you think? Go back to Algebra 1. What are some tools that we know of in Algebra 1 that we could probably use?
Yo, would you plug x squared into y?
Ooh. A little substitution? I don't know. So going from here, taking this, so plugging x squared into y. So you want to go into there?
Yeah, sure.
Okay, I guess. What do you think? Is there another way I can do that too, though? I like what you're saying. I think you're on the right idea. Or is there another way I can do it too? Uh-oh, someone's sleepy. Yo. Put y in for x squared. So plug y in for that. Okay. I think are both legitimate. Which would be the better way to do it? Plug the x squared in for y. if I plug the x squared in for y, I'm going to wind up with x to the fourth. If I plug the y in for the x squared, I think we might be able to solve that. So if I plug the y into the x squared, that's a direct substitution. That's going to allow us to take this equation and say that it's going to be y plus y squared is equal to 36. Whoops. That's a y first. I'm sorry. Okay? And let's build on that. So if I had y squared plus 1, or y squared plus y is equal to 36, can I complete the square off this problem? So I'm going to get y squared plus y equals 36. Made a space. What's the lead coefficient here? What's half of 1? Half. What's half squared? 1/4. I'm going to add 1/4 to both sides. Still with me? All right. So that means that this is going to be y plus half, quantity squared, is equal to 36 over 4. Or 36 plus 1/4, which would be, I could convert this to 144 over 4. So that becomes 145 over 4. And if I take the square root of both sides, don't forget the plus or minus. So I'm going to get y plus half is equal to plus or minus the square root of 145 over 2. So then I'm going to get y equals negative 1 plus or minus root 145 over 2. What do we know? What do we just solve? It's what? I'm not going to use quadratic. I mean, I could have used quadratic, but it's now solved. What part of my answer is that? That's the y component. What did we say originally about the y component of the problem? What's that? Originally, when we had the graph, the x, y being green, what did we say about the y component? It's the same, but negative 1 plus or minus square root 145 over 2. So look at our picture that we have. Is that a positive y component or a negative y component? Positive. So which of those should I use? Negative 1 plus. Good. So my solution for my y component, at least, so these y components here and here are going to be the exact same. So I'm going to get negative 1 plus root 145 over 2. That's going to be above the x-axis. If I use the other one, to be down here. So we're not going to use that. And then how would I get my x component now? Plug it in. So I think this would be the easier one to plug into. How would I solve this one? If I know that y equals x squared, what is x equal to with the relationship? Square root of y? Do what? Go over. So I'm going to plug this in, and I know that my x component is going to be the square root of y, negative 1, plus or minus the square root of 145, all over 2.
Wait, can you have a radical under a radical? Under the root under a root.
I like it.
You can do it?
Yeah, it's pretty ugly, but I like it. Okay? So, yeah, you're absolutely right to say that, though. You know, is this possible? So my solution to this problem is going to be the square root of negative 1 plus root 145 over 2, comma, negative 1 plus root 145 over 2. And my other solution is going to be negative 1 minus root 145 all over 2, comma, negative 1 plus root 145 over 2. And that right there is called an exact answer, and I would say go try and figure that out on your calculator. To answer your question, yes, we absolutely can have a radical and under a radical. Okay, but it's just kind of nasty math. when I say that, I'd say leave your answers like that. Don't go, oh, I can start using my calculator because goofy stuff starts taking place. All right, I wanted to go over a little bit of page 237, if that's okay. Some questions. So the assignment was page 237, 29 to 37 odd, 49 to 59 odd, 67 and 69. Are there any of those you'd like me to go over at this point? 55. 5? Okay. What else? What else beyond 55?
67.
67? You're good. What else? Anything else?
While you're looking, I'll just write these down.
Any others you want me to go over from this page? 5, 9? Uh-huh. Talk. Yes. Anything else? Good? Seems like a good start to go through. And again, I'll mark this off tomorrow, okay? But we go over, run through these few right now. All right, so problem number 55. I'd like to solve this, so I think the first move I should do is I need to move the 5 over. So I wind up with x minus 5 over here. Okay, so now I have two different things. I think it's important to put this in parentheses. Square both sides. That's going to do the radical, so I'm left with x minus 3 over here. FOIL this out. So that's going to give me x squared minus 10x plus 25. So I'm going to make this side 0, so I'm moving the x over, so that's going to subtract, and I'm going to add the 3 over. So I'm going to x squared minus 11x plus 28. What two numbers multiply together to give me 28, add together to give me negative 11? 7 and what? 7 and 4, are they both positive or both negative? Or one of each? Both negative. Okay. So I'm going to solve this. So x is equal to 4 and x is equal to 7. What should we do to make sure this works? Plug them back in. Okay. What was the kind of solution called if it doesn't work? Extraneous. Awesome. Okay. So 4. If I plug 4 in, 4 minus 3 is 1. Square root of 1 is 1. 1 plus 5 is 6. Is 6 equal to 4? Wait, did I do that right? Plug 4 in. 4 minus 3. That makes that 1. Square root of 1 is 1. 1 plus 5 is 6. And I was plugging 4 in. It's not going to work. Okay, see if 7 works. 7. 7 minus 3 is 4. Square root of 4 is 2. 2 plus 5 is 7. If I plug 7 in for x, does that still work? So this is an extraneous solution situation, whereas x equals 7 is the only of the two solutions to work. Okay, guys and girls, I'll tell you this. That would probably be a 4-point problem on a test. If you get down to this point and you say they're both solutions, this is probably worth 1 point off of a 4-point problem. Okay, so make it known that one of the solutions won't work. But make it known where you're crossing it out. Don't, I guess I guess if you had one circled and the other not, I think that might tell me that you do understand that one of the solutions works. But just to make sure, because I'm going through quickly and I'm not trying to goof it up on you, but I want to make sure you're all right. All right, number 67. I'm going to move this portion over so I don't have a negative radical. Is that okay so far? From there, I think I put this in parentheses, and square. So that's just going to give me x here. And I'm going to FOIL this out. So if I FOIL this out, I'm going to get 1 plus 2 root 3 minus 3. And then last would be 3x minus 3. Let's combine some like terms. The 1 and minus 3 are going to combine, so I'm going to get this. It's 3x minus 2. I think I can bring this over. So that's going to give me negative 2x plus 2 is equal to 2. Divide both sides by 2. So that's going to give me negative x plus 1 equals this. Put that in parentheses and refoil it. Square both sides. So that's going to give me x squared negative 2x plus 1 equals 3x minus 3. Bring that over. Holy cow, that's a bigger problem. Minus 5x plus 4 equals 0. If I factor that out, what two numbers multiply to give me 4, add together to give me negative 5, negative 4, and negative 1. So it looks like my answers could be, does 1 work and 4 work? All right, see if 1 works. Square root of 1 is 1. 3 times 1 is 3. 3 minus 3 is 0. Square root of 0 is 0. So I get 1 minus 0, which is 1. That definitely works. If I plug 4 in, I get square root of 4, which is 2. This is my head. Minus 3 times 4 is 12. 12 minus 3 is 9. Square root of 9 is 3, so I get 2 minus 3 is equal to negative 1. Is negative 1 equal to 1? The answer is no. That's the extraneous solution, so my only answer that works there is 1. So that's kind of a nasty problem. There's a whole lot of steps that you have to go through in order to solve that problem. And then the final question we had. Yeah, absolutely. So going in suit with what we just did, put this in parentheses. Square, square, so I get 3x plus 3 equals x squared plus 2x plus 1. If I FOIL that out, 0 equals x squared minus x minus 2. So that's going to be x minus 2 and x plus 1 if I factor it. So x equals 2, x equals negative 1. And let's see which one works. 3 times 2 is 6. 6 plus 3 is 9. Square root of 9 is 3. And then if I plug a 2 in here, 3 equals 3. That definitely works. If I plug negative 1 in, 3 times negative 1 is negative 3. Negative 3 plus 3 is 0. Square root of 0 is 0. Negative 1 plus 1 is 0. So both of our solutions work in this case. We don't come up with an extraneous solution. Is that all right? Ready to solve rational equations? I'm off my soap stand. I'm sorry. I shouldn't have gone there with you guys. You know, hey, life is fun. All right. So we want to solve this. So I have x minus 8 over 3 plus x minus 3 over 2 is equal to 0. So first thing I want you to notice up here, I do have fractions, but I don't have any of the letters in the fractions. Do you agree? Make sense? Okay. So that means that I don't have to worry about any undefined terms. So if I wanted to go and possibly solve this problem, there's a few ways I could go about it. I could clear the denominator, which is a pretty neat skill. If you learn how to clear the denominator, that means you no longer have to deal with a fraction. So what would I have to multiply all three terms by in order for the 3 and the 2 to go away? 6. Love it. So I'm going to multiply each term by 6. So that cancels and that gives me 2. So I get 2, x minus 8, go up, is equal, plus, that goes to that. Do you agree with that? Is that okay? Let's distribute over. Uh-oh, too much talking. You guys are talking too much. Is that okay? Combine some like terms, so I'm going to get 5x minus 25 is equal to 0. So 5x is equal to 25. So I'm going to find that x is equal to 5. Now again, I had fractions in the beginning. I didn't have letters in the fractions. So I didn't have variables in the fractions, so I don't have to worry about undefined terms. So in this case, we're going to find that x is equal to 5. Truly, if I plugged it back in, it should work. So I'm going to get 5 minus 8, which is negative 3. Negative 3 over 3 is negative 1. And then 5 minus 3 is 2. 2 over 2 is 1. So I'm going to get negative 1 plus 1, which is 0. So it totally works. Okay? So the next problem that we're going to look at is this one. First thing that sticks out is what? I have a variable in the denominator. So right now, what term can't work up here? 3. Why is that? Can't have divide by 0. So I know right now x is not equal to 3. Okay? I can go solve the rest of the problem right now, which is fine, but I have to know that we can't allow x to equal 3 without this problem set up. Is that all right for the first move? Okay. Next move, I guess I could bring the 9 over. So I'm going to do x squared over x minus 3 minus 9 over x minus 3. I think that's okay to do. And being I do have the same denominators, that's going to give me x squared minus 9 over x minus 3 equals 0. And does it appear that x squared minus 9 can factor down? What does x squared minus 9 break down to? X plus 3, x minus 3. Good. So x plus 3 and x minus 3, all divided by x minus 3, is equal to 0. That cancels out, so I get x plus 3 is equal to 0, so x is equal to negative 3. So how do I write the solution to this problem? What can x not be equal to? 3. What is x equal to? Is negative 3 and positive 3 the same thing? No, so you need, so this is done right here, and this will have to do something with graphing later, but then you have to know this. If you go and plug it back in, does that work? Well, that gives you 9, and negative 3 minus 3 is negative 6, 9 over negative 6, so those are both going to work just fine. But I have to know that x cannot equal 3, and if our answer would have shown this, this would have meant the answer has to be no solution. But being that negative 3 and positive 3 are two different numbers, we don't have to stress about that. Last one. I don't have a denominator, but what do I have? I have a root. What do you know about roots? Wakey, wakey, it's bakey. What do I know about radicals? I can square them, get rid of them. What? What else? If I had the square root of x plus 7, what's the smallest value that x can be? Negative 7. Good, because I can have the square root of 0, right? So things that should kind of stick out with you here is my answer has to be x is greater than or equal to negative 7. I have to have that as part of my answer. So if I had an answer come out here as negative 10, let's say the answer works out that x equals negative 10, it's not going to work. Okay? So we have to realize because of this radical here, our answer has to be greater than or equal to negative 7. Again, if I were to take negative 7, plug it in, I get negative 7 plus 7, which is 0. Square root of 0 is 0. All right, so let's solve this problem keeping this in mind. So I have x plus 7 over here, and I'm going to make that equal x minus 5. I just subtracted 5 from both sides. Let's group. So I'm going to square both sides to get rid of the radical. So that's going to give me x plus 7 here. FOIL this. That's going to give me x squared minus 10x plus 25. Move these over, so 0 is equal to x squared minus 11x minus, subtract, or plus 18. What two numbers multiply together give me 18, add together give me negative 11. Negative 2 and negative 9. Thank you. Okay, so x equals 2 and x equals 9. Now we already said, do both of these answers satisfy that? Is 2 greater than negative 7 and is 9 greater than negative 7? So both answers could work. Let's make sure we don't have the extraneous solution. Okay, I'm going to plug 2 in. 2 plus 9 is, or excuse me, 2 plus 7 is 9. Square root of 9 is 3. 5 plus 3 is 8. Is 8 equal to 2? No. So this is not going to work because it's extraneous. Plug the 9 in. 9 plus 7 is 16. Square root of 16 is 4. 5 plus 4 is 9. If I plug 9 in for x, 9 equals 9. That's my solution. It also fits within my data set. All right, I want to give you the opportunity to work on the assignment. Remember, I'm going to, so this will be due This was from Friday. I said it's due tomorrow. And I worked out a couple of those problems, okay? Okay, so first thing, tomorrow I'm collecting this. Don't do this, don't do them both on the same. I know you're trying to save the trees. Don't worry. We're Americans. We realize that global warming and destruction of forests doesn't really exist because it doesn't satisfy our lifestyles. So I'm just saying. But this will also be checked off tomorrow. Page 236. So this was assigned on Friday, but this one down here will be new. So 1 through 15 odd and also number 19. Okay, so you have both of those. You have the opportunity to work. We got a few books up here. Grab them.